Hello and welcome to lesson 1 of week 15. We're going to focus on graphing to solve a system of equations. So I can determine the number of solutions to a system without graphing. So I'm telling you that you'll be able to do this without graphing, and you can tell how many solutions they'll have and be able to find the solutions by actually graphing. So you might recognize this question from the introduction. I'm going to show you a little bit of how we can solve this. We're actually going to solve this by graphing. So we're going to define the variables. What are we trying to find? How many of each type of ticket are in the box? So there's adult tickets, and there's also child tickets. So A is going to represent the number of adults tickets, and C is the number of child tickets. Writing the equation. So there is an equation that represents the total number of tickets. So if you add the adult tickets plus the child tickets, you should get 95. Now there's also an equation that represents the value. So 8 times A would represent the value of the adult tickets. That's how much money they would make from adults. 5 times C is how much money you'd make from the child tickets. If you add those two amounts together, you get the $640. And then we're going to graph them on the next slide to find the solution. All right, so I'm going to use intercepts here. It's not what I would recommend doing, but for this problem here, just to show you how this works, I'm going to use intercepts. So that means what happens if I don't sell any adult tickets? If they were all child tickets, there would be 95 tickets in the box. If there were no child tickets in the box, so 0 represents, how many adult tickets would I need to sell? 95 as well. So if I put those points on the line, on the graph, 0, 95, and 95, 0, and connect those with the line, the points on that line represent all the combinations that would be 95 tickets. Okay, it's not just those 2 points, but there's any point on this line would represent a possible solution. Let's do the same thing with the other one. If I have 0 adult tickets, I would have 95 child tickets, but how much would each one, or how many of them would I need to make $640? I would need 128. 640 divided by 5 is 128. What if I had 0 child tickets? Well, 640 divided by 8 would be, I would need 80 adult tickets. So that represents 2 more points that makes another line. So 0, 128, and 80, 0. Connect those, and you see that those 2 lines intersect right there. And our job is to find out what that is. Now, it's really hard to tell on this graph. I'm going to tell you that they intersect at that point right there, 55, 40. That is my solution. That's the combination that would satisfy both of those situations. We can check it to make sure. So I'm going to put 55 and 40 in for A and C. 55 plus 40 is 95. So 95 equals 95. That's good. 8 times 55 plus 5 times 40, that equals $640, which means that it's also true. Now, what are you going to be expected to do? It's going to be something a little more like this. These are in slope-intercept form, a little easier to graph. So let's go ahead and graph the first one. Y equals x plus 2. The y-intercept is 2. The slope is 1. So I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. Let's draw our line. Notice I'm putting multiple points on the line. It's a good habit to get into. Let's graph the second one. The y-intercept is 5, and the slope is -2. So that's down 2, right 1, down 2, right 1. And you can see that they have intersected. Let's go ahead and draw the line, though. Do you see how they've intersected right there? Let's name that point. That is the point 1, 3. X is 1, y is 3. And that is my solution. And I can check it to make sure. So I'm going to put 3 in for y and 1 in for x and see if the left side is equal to the right side. And it is. Let's do it for the second equation. Put 3 in for y and 1 in for x. So 3 equals -2 times 1 plus 5. So let's simplify the right side there. -2 times 1 is -2. -2 plus 5 is 3. 3 equals 3. It's correct. All right, so how do I find the number of solutions to a linear system? Well, we just saw in the previous example that if they cross, there's one solution. 2 lines are never going to cross a second time. Okay, they're not going to cross once and then curve back and cross again. That's not how they work. So you could have one solution. You could also have the situation where they never cross. Those are called parallel lines. If they're parallel and never cross, that means there's no solutions. And you could also have infinitely many solutions, meaning if they are the exact same line, they would be laying on top of each other, they would intersect everywhere. All right. How can I tell by looking at the equation without graphing? Well, you want to look at their slopes. We've talked about this with parallel and perpendicular in the past in week 14. So let's look at their slopes. Well, the first one, the slope is 1, but the second one's in standard form. I need to get it into slope-intercept form. I'm going to add x to both sides, which is going to give me y equals x minus 1. Are the slopes the same or different? Well, they are the same, right? They're both 1. So then that means they're either parallel or they are the same line. So how do I tell the difference? I got to look at their y-intercepts. These are actually different, right? One's positive 1, one's negative 1. They're different. That's enough to be able to answer how many solutions this system has. If they have the same slope and different y-intercept, they're parallel, which means they have no solutions. I'm going to show you the graphs just to make sure you see that. Okay, you see that those have the same slope, different y-intercept, therefore they never intersect because they're parallel, so there are no solutions. So quick summary here. Parallel lines have no solutions because the lines do not intersect. If the lines are the same, meaning they have the same slope and the same y-intercept, then there are infinitely many solutions because they're the exact same line. If the lines have different slopes in any way, so one's positive, one's negative, you can be sure that they will intersect somewhere. And if they intersect, they will have one solution. And that concludes lesson 1.